Oke. Oke. Baik, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat datang, selamat siang kepada seluruh peserta webinar BIM Allplan pada hari ini, hari Senin, tanggal 15 Juni 2020. Baik, Bapak Ibu semua, kali ini kita sebelum memulai materi inti dari tim Allplan, kita akan mendengarkan sambutan sekaligus pembukaan dari Bapak Kepala Balai Penerapan Teknologi Konstruksi, Bapak Cakranagara STM TNE, mengenai bagaimana pembinaan SDM bidang BIM di Indonesia. Kepada Bapak Cakranagara selaku Kepala Balai Penerapan Teknologi Konstruksi, kami persilakan.
Oke, thank you Pak Reza. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Yang kami hormati Mr. Siswanto, Mr. Ulrich from Allplan. Kami ucapkan terima kasih. Ini adalah pertama kali kita melakukan webinar bersama antara Balai Penerapan Teknologi Konstruksi, Direktorat Jenderal Bina Konstruksi bersama Allplan. Allplan ini adalah salah satu provider dari BIM yang berasal dari Jerman, setahu saya demikian, yang tentunya banyak sekali hal-hal yang akan kita dapatkan dalam webinar ini. Nah, Pak Siswanto, Mr. Ulrich, dan Bapak Ibu sekalian, saya akan membawakan tentang bahan presentasi atau pengantar tentang capacity building teknologi perancangan menggunakan BIM untuk mendukung konstruksi digital. Mungkin ada beberapa dari Bapak Ibu yang sudah mengenal bahan ini, tapi tentunya kami harus sampaikan berkali-kali karena supaya kita memiliki visi yang sama terkait dengan bagaimana teknologi informasi ini, terutama BIM, dapat diimplementasikan di Indonesia. Oke, selanjutnya. Bapak Ibu sekalian, kalau kita melihat dari slide ini, kita sudah melihat tentunya bahwa saat ini Indonesia memiliki daya saing yang menurun. Rankingnya dari 36 ke 45 dan daya saing infrastrukturnya menurun dari 52 ke 71. Hal ini disebabkan karena salah satunya masalah adaptasi teknologi. Di sisi lain, Indonesia tetap menjadi pasar dari market dari konstruksi nomor 1 di ASEAN dan nomor 4 di Asia. Jadi banyak sekali investasi di bidang konstruksi yang masuk ke Indonesia. Lanjut. Bapak Ibu sekalian, ini adalah struktur dari Badan Usaha Jasa Konstruksi Nasional. Indonesia memiliki 140.000 badan usaha, yang besar 1,4%, menengah 14%, yang kecil 83%. Ini adalah badan-badan usaha yang memang strukturnya besar di bawah, besar di bagian kecil. Kita berharap bahwa ke depan banyak perubahan struktur, terjadi perubahan struktur menuju spesialis. Kita di sini akan mengenalkan BIM. BIM ini saat ini untuk beberapa BUMN di bidang jasa konstruksi, BIM sudah banyak dilakukan. Kita berharap BIM juga dapat dikenalkan atau dimiliki oleh badan usaha menengah dan kecil. Lanjut. Bapak Ibu sekalian, ini adalah komposisi tenaga jasa konstruksi nasional. kita memiliki 8,3 juta tenaga kerja. Ahlinya hanya sekitar 300-an orang. Terampilnya hanya sekitar 2 juta orang. Sisanya unskilled. Ada suatu fenomena di Indonesia bahwa saat ini tenaga kerja konstruksi di level ahli muda itu menurun. Padahal tenaga ahli kerja sektor konstruksi ahli muda adalah menjadi backbone dari pembangunan nasional. Lanjut. Bapak Ibu sekalian, ini adalah lingkungan strategis terkait dengan bagaimana kita mengenal industri jasa konstruksi, khususnya masalah SDM. Kita mengenal revolusi industri, kita mengenal spesifikasi teknis, kita mengenal segala regulasinya. Hari ini kita akan berbicara tentang BIM. Kenapa? Kita lihat slide selanjutnya. Lanjut. Bapak Ibu sekalian, dalam menghadapi revolusi industri, ada 3 hal yang kita lakukan. Dilakukan oleh Kementerian PUPR, Direktorat Jenderal Bina Konstruksi. Pertama, kita melakukan distance learning di Bina Konstruksi. Hal ini dilakukan untuk menjamin bahwa para tenaga konstruksi di Indonesia memiliki pengetahuan dasar sesuai dengan SKKNI, Standar Kompetensi Kerja Nasional Indonesia. Ini adalah dasar, lower strategi. Kemudian BIM, Capacity Building, BIM. Ini adalah upper strategi, dan selanjutnya upper strategi lainnya adalah magang di bidang konstruksi. Lanjut. Bapak Ibu sekalian, hari ini kita membahas tentang BIM. Mengapa BIM diperlukan? Jadi ada suatu historis di kondisi masa lalu di Indonesia bahwa dulu itu data-data kurang terdokumentasi dengan baik. Proyek-proyek kurang terintegrasi sesama proyek. Para tenaga ahli sering terjadi dispute. Itu menyebabkan inefisiensi dan inefektivitas. Tantangan ke depan adalah pekerjaan kompleks. Tantangan ke depan, visualisasi dari dokumen kerja diperlukan. Tantangan ke depan juga kita memerlukan low cost dan tepat sasaran. Maka itu kita memerlukan BIM. Lanjut. Bapak Ibu sekalian, kalau kita lihat definisi BIM, BIM adalah metode. BIM bukanlah software. Jadi BIM merupakan metode kita melakukan integrasi data. Data-data diintegrasi. Kemudian terjadi kolaborasi antar tenaga ahli dan antar data. Kemudian data-data itu hidup, tidak mati. Sehingga dengan demikian kita melakukan visualisasi dengan BIM. Lanjut. Visualisasi yang kita lakukan bisa berupa 3 dimensi sampai 7 dimensi. 3 dimensi artinya panjang kali lebar kali tinggi. Sedangkan 7 dimensi itu kita urai dulu. Dimensi keempat adalah volume. Dimensi keempat adalah scheduling. Dimensi kelima adalah volume dan kuantiti, volume atau quantity. Dimensi keenam adalah energi. Dimensi ketujuh adalah operation and maintenance. Lanjut. Bapak Ibu sekalian, oke. Ini adalah arahan dari Menteri PUPR bahwa ke depan untuk melakukan terobosan dalam pembangunan diperlukan banyak hal. ada 5 hal yang menjadi titik concern pimpinan kita. 2 di antaranya yaitu sumber daya manusia dan penerapan hasil riset dan teknologi. Bapak Ibu, kalau kita lihat regulasi berdasarkan peraturan Menteri PUPR nomor 22 tahun 2018, di situ disebutkan bahwa pemerintah saat ini memiliki regulasi yang ketat terkait dengan bangunan gedung. Bangunan gedung untuk di atas 2 lantai dan di atas 2000 meter persegi wajib menggunakan BIM. Sebenarnya pertanyaannya adalah bangunan gedung yang mana? Pertama itu merupakan saat ini diperlukan untuk bangunan negara. Apakah bangunan bukan negara diperlukan BIM ke depan? Iya, tapi saat ini sedang dalam kajian untuk menggunakan diberlakukan pada bangunan-bangunan komersil. Yang kedua, apakah itu merupakan anggaran pada posisi APBN saja? Ya, APBN tapi meliputi seluruh kementerian. Yang selanjutnya, apakah hanya di pusat saja? Tidak. Regulasi Permen PUPR nomor 22 tahun 2018 ini berlaku untuk seluruhnya, baik di pusat, provinsi maupun daerah. Jadi, hanya dengan peraturan Menteri PUPR ini kita bisa melihat kebutuhan BIM di Indonesia sangat-sangat besar. Selanjutnya, apa yang harus kita lakukan dalam meningkatkan pengetahuan BIM, yaitu kita harus berkolaborasi. Kita mendukung kolaborasi quad helix. Di situ ada pemerintah, ada badan usaha, ada industri, dan ada masyarakat. Pertanyaannya, apa yang didapat oleh pemerintah untuk setelah pemerintah menerapkan BIM? Pertama, pemerintah diuntungkan dengan data. Sustainabilitas data itu diperlukan oleh pemerintah. Bapak Ibu sudah melihat data-data yang tidak sustain menyebabkan pembangunan kacau balau. Jadi dengan BIM, data-data yang dimiliki oleh pemerintah sustain dan bisa digunakan untuk pembangunan selanjutnya. Bagaimana dengan bisnis dan industri? Kalau kontraktor konsultan memerlukan perhitungan yang cermat untuk mendapatkan keuntungan, gunakanlah BIM. Bagaimana dengan masyarakat? Masyarakat yang tertinggal, tidak adaptif terhadap perubahan, maka dimungkinkan akan kehilangan banyak hal, terutama masalah dari sisi income untuk perencanaan. Bagaimana dengan akademisi? Akademisi memerlukan kolaborasi riset. Jadi kalau dulu riset dilakukan dengan sendiri-sendiri, sekarang diperlukan kolaborasi riset. Yang satu lagi yang menjadi kami highlight adalah rencana pemerintah ke depan. Bapak Ibu sekalian, kita sudah melatih cukup banyak ahli-ahli BIM, namun saat ini masih kurang. Sehingga ke depan kita sedang akan melakukan capacity building terhadap BIM. Kita berharap Allplan juga berkontribusi dalam hal capacity building untuk masyarakat jasa konstruksi. Demikian yang bisa kami sampaikan. Terima kasih. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih Pak Desa. Pak Takra. Pak Desa mau menjelaskan mengenai link dan seterusnya?
Oke, Pak Sis, saya mau jelasin ini aja itu yang tadi.
Silakan,
Baik,
Pak.
terima kasih Bapak Kepala Balai Perawatan Konstruksi, Pak Cakra Negara atas sambutan sekaligus pembukaan dan pemberian pencerahannya tentang pemimpinan BIM di Indonesia. Baik, selanjutnya saya ini atas nama panitia mau mengumumkan beberapa hal. Yang pertama untuk Bapak Ibu, rekan-rekan semuanya yang memang masih belum bisa berhasil masuk ke GoToWebinar, nanti video dari webinar ini, rangkaian webinar BIM bersama akan kami upload di YouTube channel si Bima Konstruksi. Sekali lagi, nanti video rekaman dari webinar ini akan kami upload di YouTube channel si Bima Konstruksi. Itu yang pertama. Kemudian yang kedua, Bapak Ibu mohon nanti bisa stay terus mengikuti jalannya webinar ini. Nanti di akhir menjelang penutupan menjelang akhir dari sesi webinar ini, kita akan bagikan link feedback dari feedback dari untuk peserta. Nanti silakan peserta isi link itu untuk mendapatkan e-sertifikat. Sekali lagi nanti kita akan bagikan link feedback melalui chat room yang ada di pojok kanan bawah ya. Mungkin sama Bapak Ibu juga, nanti kita akan di copy paste di browsernya Ibu Bapak, nanti diisi datanya, kemudian namanya tolong dibuat yang rapi ya, huruf depannya besar misalnya gitu, kemudian ditambahin gelar akademik silakan, pokoknya rapi, karena nanti itu akan menjadi nama sertifikat. Kalau misalkan nanti ada kesalahan-kesalahan pada nama Bapak Ibu, kami tidak tanggung jawab dan tidak akan ada pergantian nama Bapak Ibu karena kesalahan penulisan nama dari Bapak Ibu sendiri untuk sertifikatnya. Itu saja mungkin yang bisa saya sampaikan. Nanti kita akan bagikan linknya mulai sekitar 30 menit sebelum sesi webinar berakhir. Itu saja, terima kasih. Kami serahkan kepada Pak Siswanto. Silakan Pak Sis.
Terima kasih Pak Reza. Arif, I think they are done. So you can start first presentation with Stevens. Or I think it will be Ramon first, ya. Ramon, go ahead.
Yes, can you see my screen all?
Yes.
Yes. Okay, then good afternoon and welcome from my side to this webinar. My name is Ramon Steins from Allplan, and I'm working in the Sales Enablement Department, and in that role responsible for the support to our Indonesian partner PT Piranti Sarana Technologi, led by Mr. Siswanto. We have introduced Allplan in Indonesia back in 2018, and quite some projects have been delivered since then with the help of our software. Today, we are given the opportunity to share all relevant information on Allplan with you, and I would like to thank the PUPR for organizing this webinar series that gives us the chance to demonstrate the capabilities of the Allplan solution portfolio in infrastructure projects. Allplan is in fact one of the brands from the Nemetschek Group, and the Nemetschek Group has been founded by Professor Georg Nemetschek in 1963. Allplan was the brand it all started with, and the one that has been created by the professor himself. Allplan has been a 3D software from the start, and was already a BIM software long before the word BIM was invented. Allplan is created by experts for experts, and share with all other Nemetschek brands the same philosophy. We are open and declare our support of Open BIM, a standard that allows maximum flexibility and a seamless collaboration among all the parties involved in the construction process, so that quality is enhanced in construction in compliance with time and cost schedules. Nemetschek drives digitalization and innovation for the entire life cycle of the AEC industry, and has the vision to be the innovation driver and digital backbone of the AEC industry. The 16 brands have a proven expertise and a close proximity to the market and the customers. To strengthen this story, I can mention some figures about the Nemetschek Group. We are more than 2,500 employees and serve more than 5 million users all over the world. We operate in 143 countries, in which we have 82 locations. If we speak about the entire life cycle of the AEC industry, we see 3 different phases: design, build, and manage. Nemetschek is represented in all of these phases with different brands, and on top of that we cover a 4th discipline, media. But for today we will focus on design and build. In design, it's all about creative, detailed and precise design, from the early design phase to construction and building planning. And for the build phase, Nemetschek offers comprehensive 5D solutions that cover the full spectrum of BIM. The brands that operate in these phases can be seen here in this scheme. For the modeling, design and development, Nemetschek offers Graphisoft and Vectorworks for architecture, DDS for MEP, and Allplan for engineering, both civil and building engineering. For structural design and analysis, it's Kia, Risa, and Frilo. And for detailing, especially rebar detailing, it's Allplan. For steel detailing, we have SDS2, and for fabrication of precast concrete, we offer Planbar. Planbar continues this webinar series on Thursday and Friday with 2 sessions in which they will demonstrate their solution. Today's webinar is all about Allplan, more specifically Allplan Engineering. And then let's start with some figures about Allplan itself. Headquarters of Allplan are in Munich in Germany, and we have offices in Austria, Switzerland, France, Spain, Italy, the Czech Republic, Slovakia, the UK, and the USA. Allplan employs more than 400 people in those countries. 240,000 users use Allplan on a daily basis, and we work closely together with 23 strong technology partners in 12 different countries. Allplan comes in a few different flavors. There is Allplan Architecture, Allplan Engineering, Allplan Bridge, and Planbar from Precast. BIM Plus is the data hub in between that connects all those flavors with the other Nemetschek brands and even third-party software. More about BIM Plus will be in the webinar on Wednesday. Let me shortly explain the different flavors before we go to the software itself. Allplan Architecture is a focused BIM tool for architects that comes with extensive CAD functionality. You can work in 2D and 3D simultaneously, and it creates efficient and quality construction drawings as well as high quality and reliable quantity takeoff. Allplan Architectures offers full render capabilities using the integrated Cinema 4D render engine. And then about Allplan Engineering, the product we are speaking about today. It's a focused BIM tool for structural and civil engineers. Also here you can work in 2D and 3D simultaneously. It's a BIM tool with extensive CAD functionality that is capable of creating efficient and quality construction drawings, as well as high quality and reliable quantity takeoffs. Allplan offers a focused 2D and 3D solution for rebar detailing. And unique is the two-way integration with structural analysis and design. With Allplan Engineering, you can work efficiently between designer and detailer. The latest addition to the Allplan solution portfolio is Allplan Bridge. Allplan Bridge is the professional BIM solution for bridge construction. Engineers work with a single solution from parametric model creation, with a high level of detail including pre-stressing, to integration of the construction process and structural analysis of the bridge model. Allplan Bridge offers you an optimal BIM workflow for bridge construction, common 4D parametric data model for detailing and analysis, innovative and BIM compatible global structural analysis. And there is BIM Plus. Collaboration. It lets you visualize and analyze data from the entire project team. You can merge models from multi-disciplines project teams. It's an open platform for all software. Collaboration is possible using the standard formats IFC and BCF, and it offers powerful API capabilities and can be used on all modern mobile devices. Then now finally we can go to the software itself. It's actually the good part of the webinar. Today is all about Allplan Engineering, and let me introduce the presenters for this webinar series to you. Today you will hear Stefan Binnemans the most. Stefan is Sales Enablement Manager and an experienced Allplan consultant. His focus is on civil engineering and his specialty are bridges. Stefan will give his best to demonstrate Allplan to the max. Also tomorrow, when we speak about the Allplan Bridge solution, he will be your host. And then there is Ralph Pullinger. Ralph is also working in the Sales Enablement department, and he will cover the BIM Plus topic on Wednesday. Today and tomorrow, he will assist Stefan in some workflows. So I will hand over to Stefan now and wish you all a pleasant webinar.
Okay, hi everybody. Good afternoon there in Indonesia. You can all see my screen?
Yes.
Okay. So there are maybe 3 parts in this presentation. I will first go over some reference projects. In the end, there will be some hands-on modeling and a rebar introduction. And then in the end of the presentation, there could be some time to Q&A. First, I will start with reference projects. What is the idea about these reference projects that I will show maybe more in-depth looked in some of the case studies. So on the Allplan website, there are case studies, which is a PDF document explaining these different projects. But I will show these projects live in Allplan so you get a better understanding and a more in-depth look or behind the scenes of how these projects have been created, how they can be used in Allplan, what they bring to the designer and the contractor for the construction. So we see here for Tamina Bridge, for example, we have another one which is the Drydock in Dukum in Oman, and so you see your case study Tamina Bridge is also one. So I will show a couple of these. I think I will show in total about 5 or 6 projects, and then you can take a look at these case studies also to get then also the other side of the story. First one is for Tamina Bridge in Switzerland. It's over a gorge in the mountains. It's about 150 meters long, and the span between these supports is 80 meters. We'll take a look at the 3D model to see construction phases and also to see what is inside of this model, where you can see the rebar. And then we can also check the rebar stages. We'll also take a look at drawing to see how this can be represented, for example, with the Swiss standard. Next project is the Drydocks in Dukum in Oman. It's part of a large harbor project. These are 2 dry docks for about 400 meters long and 100 meters wide. And we'll also see how a massive project like this can be managed, how these individual elements can be reinforced and managed. Next is the Tamina Bridge, fairly recent bridge in Switzerland also, and the construction sequence was quite special. I will show you this also in Allplan later, how you can see this or simulate this from the 3D model itself. The total length is about 450 meters, and this main span here is 260 meters. And I think the gorge for the river below is also about 250 meters high. And we'll take a look here to see in this project also a lot of pre-stressing tendons together with a rebar detail. Then another one is a railway bridge in Belgium. This looks like something very simple, and it's just one cross section. It's not so long, it's about 100 meters long, and the main span is 35 meters. But I will show what is interesting in this project because it's a very simple structure, but the detailing is very complex. You can see the tendons, and there's also something special with the supports which make this very complex. Next project is then a civil engineering project, and you would say this is a tunnel, but it's actually an aqueduct. This part that we see here is a canal for the boats to cross the road. So you could say this is tunnel, but to say it nicer or more special, this is actually a bridge for boats to go over the highway. And we'll take a look also about rebar detailing in this segment of the project. Then we come to the last reference project, which is the flyover Keresheide. It's in the Netherlands, not too far from where I live. I live in Belgium. Ramon lives in the Netherlands, so it's between the two of us. We always pass by this under this flyover. It's about 650 meters long, and you have 11 spans of about 50 to 60 meters between the piers. And here we'll also take a look at rebar detailing, construction stages, and you also see here the tendons. For tomorrow, Allplan Bridge, I can also highlight the possibility of creating these tendons in a segment in Allplan Bridge. So today we'll be focusing on these reference projects and showing some workflows or what the 3D model can mean in a BIM environment for the designer and for the constructor. Okay, so let's go to Allplan. Yes, so we start off with Versammeltobel Bridge in Switzerland. We can see also that in Allplan you can have your digital terrain model to see how it fits into the environment. And yeah, we can check also the 3D model and then see, for example, the detail for these guardrails. We can see in the bottom that we have these tendons. Yeah, so you get a good overview, or you can imagine how this project would fit in a 3D terrain, for example. Okay, now I will also show some functionalities for Allplan. In this case, you have this curved road. There is the bridge itself is straight, but you have functionality to represent this in a good way. And this is section along any curve. So you see here actually the road axis, and I can make a section along this road axis, which can be curved. So it can be circle, straight line, clockwise. So it can be a whole road axis. And with this function, you can just click the axis, choose the direction that you want to look, and now the model will be cut, or a section will be created along the terrain with a depth of 0 in this case. So you see here, let's make this a little bigger. So we see here that this terrain, there's a gray line, has been cut along this axis, and you see also all the elements. Now I can also make another section here along these lines. So again, you can choose from which side you would like to look, from this side maybe, and then a section will be created just through this line, and then would be that this has been taken where you have this support foundation. You can see it now here with the bridge deck and also the terrain. So it's very easy and very precise to create just a section along any curve and to see all objects, and it will be any object like a terrain, 3D lines, 3D surface. It can come also from other software. If you have there a terrain, you can just import a 3D surface, and then it will also appear on this section. More with this section, what we can do here is we can use a dimension, and then you can dimension the section and just place these dimension points, and then you will see exactly the height within the section. So this is like 700 meters high, 700. So you can just click points, and then relative to the absolute elevation, you will get these heights. Okay, so this is about the section along a curve. Now I will go back to the 3D model, and here we will take now a look at some construction stages, maybe not really stages, but to see how this model has been built up. So you have a specific structure in Allplan where you have divided your project in different files. This will be visible in all of the projects. Sometimes I will go a little bit more into detail about this. So here we have model and rebar, and we also have the terrain. So let's just say I would like to turn off the terrain here, and then we'll see the bridge and yeah, these height lines, for example. You can say, okay, I would like to leave them on, so you can also just turn them off here. And then we get a clean look at what our construction or 3D construction is. Okay, so turn off this one here, and then we see the actual bridge construction. So this is all 3D models generated with freeform modeling, and now I can say I would like to build it up from the start to show different phases. So for example, we have a foundation on this side, we have the foundation on the other side, we have then the abutments on one side, abutment on the other side. These can be subdivided in smaller parts. It's just now here to show the different elements. And this can represent also a construction stage. Then we have the main span or main deck. We have the guardrails, and for example, at the end, we have also the road covering. Same thing that we can also do for the reinforcement, but it can be done also with different detail. So we have here, for example, the rebar for abutments. And then abutment itself, we have the foundation for this supports. Then we have the support. So for a visualization, for example, you could choose, okay, I would like to show now where we have this boat also with a 3D model. Yeah, so you have this structure integrated into Allplan, where you can show how it's built up, make some visualizations of it if you want to do this. But this is a part of how you organize your projects. And then let's continue here. So we have then the support parts. Yes, we can take a look in detail a little bit more. These are all 3D rebar, and from 3D rebar, 2D design will be generated. I will show this in the last project exactly what the relation is between 2D and 3D. And now we take a look at the main span, for example, here, and then you can just add, okay, show different parts of each segment to see when the pour should be done or what rebar will be needed for each phase. Okay, let's focus maybe on just one in the middle. So I will turn off everything here and take a look at the one in the middle. So here we have a rebar, and this is actually different bar shapes with different mark numbers. And in this object tree, we can go into detail here about reinforcements. For example, you see there are 62 different bar marks, and you can say, show me where bar mark 1 is. Then you just activate it, and then you can see here, okay, this is bar mark 1. Where is bar mark 2? Something like this. So you can go through the project and still check in the 3D model where each bar mark is located. So these are, it gives some overview about how you could organize a project. So 3D model together with rebar, and now I will show you actual plan layout that has been created from the rebar. So here we see, and I can show maybe in color. So this is the design of the middle part that I showed. This is according to Swiss standard, so it can look a little bit different than what you're used to, and then you can see details of the rebar with sections. I will also show later how this works, how you can design a bar shape, and how you can create a section, and that would be in the last part today. Another layout is the one about the prestressings. So, and here you can see then a detail about prestressing cables. This is something that can be very well created, the tendons with Allplan Bridge, also possible with freeform modeling in Allplan. Okay, so that's it for this project. Now I would like to go to the next project, which is then the Drydock in Oman. Okay. So these were these two dry docks, about 400 meters long and 100 meters wide. And okay, make this a little bit lighter. So here we see our project again. So these are all, I'll show the edges. So then you can see a little bit better. So now about the scale, so 400 meters, that means one of these floor steps, this is one single pour, 40 meters long by 20 meters wide, and I think 2 meters thick, so massive elements. The engineering office is done, the construction is done by Daewoo from South Korea. In the beginning, the engineering office, they wanted to just create calculation of how much reinforcement was needed, but then just like a typical sketch or typical detail without the need of having actual details being created in 3D. They were the contractor, they had a very tight construction schedule. So they say, let's invest and put the effort in the beginning so we can actually design all these 3D elements with 3D reinforcement. So when they are poured on the construction yard, we have all the rebar being produced already, and we are sure that it can fit on the construction yard, and we don't lose time by needing to fix some problems on the construction yard, certainly for each of these massive elements. So if you check a little bit about the scale, this is, I think, about 15 meters high, 40 meters, so one segment of these walls is 50 meters high, 20 meters wide. So we can also check here. There is some access roads going to this side. So each element can be similar, but actually they're all a little bit different. Also for this gallery on top, there are connections which are more heavily reinforced. So if we take now a look a little bit into detail, for example, this drainage tunnel here. So how does the reinforcement again fit in a model like this? I can just turn off this object inside. So let's check maybe a little bit deeper. So if we see here, this is very heavily reinforced. And then we can take a look around, also see where it goes to the pump room, to the other side, so where it actually comes from. So this is the entrance, or where the water comes from the Drydock, goes to the pump room. Yeah, so this is something you also have when you have a 3D model with the reinforcement. You can check the relation and get a better understanding how these things are organized or can fit together. There will be other elements. Let's take a look at maybe one of these called sidewalls. So how would you structure a project like this? Because there are many elements and they need to be, let's say, handled individually. And you would like to be able to work with multiple people because this is a large project. So for this, there is the building structure. It's called building structure, and you can organize a project in the way that fits your needs. So what we see here is an organization, and this is very flexible. So you can create this how you would need it or see fit. So we have dock 1. Let's make this a little bit smaller here. So we have dock 1 on this side. We have dock 2 on the other side. And this is also how this is organized here. We have dock 1 and dock 2. And then we have corner walls, head walls, side walls. So let's take a look, side wall north, which is this one here. And then you have each of these elements. So N1, dock 1, north wall, number 19. So each object is numbered and each object is an individual part of the project. So let's, for example, just turn on this one here. We don't need to have the drainage tunnel anymore at this point. So you see, you can just turn on, turn off these different elements. And now we will see here everything together. If I turn off now the full model here, then we see this is this one object. And then we can take a look more into detail about just one object. So easy to manage, easy to find again in this structure where this model would be. And on the right-hand side, this is how this customer has organized it. We can have the same thing here where we take a look and for the reinforcement, for example. So now on this side, I have the 3D model. On the other side, I have the reinforcement. Open them both again. Focus on the thing that you would like to see. So not the full model, just this one. And if I turn off now, you can actually see there is already reinforcement. This is slightly transparent. So if I would turn off now the element, then you would see the reinforcement. In the different colors, each color can represent or a diameter or a mark number. So this is up to you, or a reinforcement layer. Yeah, so this is the rebar model here. Okay. So we saw the organization. We saw this drainage tunnel in detail. Let's take a look maybe at the drawing linked from generated from this model. And this is generated, I think, according to British standard. So let's just take a look at one for the drainage tunnel, one of these sections. So here we see each label. So the label can be customized. You can, for different standards, like we saw the Swiss standard, this is the more British standard. You can configure how these labels should look, and they're linked to the reinforcement. So we have the different sections here for the different parts of this drainage tunnel. Okay. This was the second project. Now let's take a look at the third project, which would be the Tamina Bridge. Tamina Bridge in Switzerland. So this was the one about 450 meters long, and this gorge of, or the cliff about 250 meters high. And what you will see first is the view of the full model. And you see that this looks quite strange. This is the purpose, of course. So you see that there is some steel construction with cables, but that doesn't really match the, could even the bridge. But what we see here is actually different states of the project or the model in one step. So I've activated everything here. So I see multiple, let's say, disciplines, multiple stages of this project at the same time. Let's maybe focus on the finished bridge like this. So we have a DTM, we have this deep gorge for a river, so about 250 meters high, I think. And the construction here on the internet, there are very nice pictures about how this bridge has been constructed. Also in the case study, there is something, let's see here, yeah. So you see this arc here, how this has been constructed. It's quite impressive because it crosses this gorge, so they need to make the formwork, and actually it's hovering over this gorge just by generating this arc segment. So first they create a support arc, and then they put the actual bridge on top. Also here I can simulate the workflow. So let's start by turning everything off. We have, of course, digital terrain, and then here we can see there is some cutouts already for the foundation. So we'll just go through here. We have the foundation on this side, and we have the foundation on the other side, and they work on both sides simultaneously. So one group works on this side, the other on this side, and they just construct then the first, let's say, connection, so some kind of abutment connection with what the road would be. And this is a massive concrete block here, where this is, oh, don't show again, I think we're full. That's good, so many attendees. So this is one massive block of concrete, and then the bridge lays on top of this and is held down with some kind of cable to hold it down on this massive concrete block. And then you would have the deck on top. So this could be done as a couple of stages, and then we have the next one is then the foundations on this side for the support parts, foundation on the other side, and then actual support is also being generated. So for this, temporary formwork is used. I didn't include this in this project here. So when this is done, now the special thing starts to create this arc. And maybe first this connection also here. So we have the bottoms, and then we have the top, so the deck. So this is actually finished and then keeps it balanced there, and this side also. And now they start with the arc. And for the arc, they need first to have this temporary construction. So here I just did it in one step. Normally it would be the erection of this part and then just each arc, but then there would be too much clicking, so I just grouped them a little bit. So we have the first, let's see, each one is a segment, and the segment is generated, and we see this clearly on this picture here also. So this is the formwork. You can see the size. It's full of reinforcements. It's a hollow core arc, but then cast in place. And you see this, each one is one of these arc elements, fully modeled in 3D. It gets thinner in height and in width, so it's also quite complex, but very efficient modeling, because it's, let's say, in relation a thin shape. So then we go to the next phase here, and then we see the next support structure and the next set of arcs. And now, because this is also a little bit lower, so they generate it and they would like to come together somewhere in the middle. So they start on this side, and now they start constructing temporary structure on the other side, and they start with these arcs here. And maybe in this arc, I can show also a little bit of the reinforcement later. So then we go to the next step. Is actually on this side, and then on the other side, the same thing. And then here, the last part with the arc. On the other side, also the temporary steel structure. So they have on two sides, and now by arranging the tension on the cables, they can move it so it can fit perfectly together. So they still have control to move it like an inch or a little bit, so it can it's perfectly aligned. And then when that's done, they put the ski in the middle. And then this structure is completed. The support structure, of course, it can support itself because it should support also the bridge on top. And then you can just say, don't show anymore the support structure. So this is the actual state, this project at this specific point. Then we can continue with the deck, and then they start in the middle. So that seems like the most risk to start on this arc in the middle without any connection there, but then they put this formwork here, very impressive construction. Okay, and then let's say first is this part being constructed, and then is the deck on top, and like this they go to the different steps where they put first there with again some temporary formwork, which is then put on top of the arc. So they work more or less in symmetry, so on each side, and then they have this both of these supports. Then they will construct the next part here, other side. So not fully symmetrical because this side is a little bit longer, so it's a very detailed design. There is nothing which is actually the same. The system is the same, but the actual design is different. So there are many variations in thickness of the deck. This would then be almost the last part there. They start from the support again, so a cantilever, and then they put the middle section. So this was finished first, and now in the end, this is then the last section here. So now the bridge is complete. Then you can say, okay, put the other elements on top, and now you have the main, or the bridge is complete right now. So this is the exterior. We see the construction stages and also the parts in the 3D model. Now let's take a look at what is inside. And for this, I will put the transparency on. I will turn off the details here. Let me collapse it again. So set the transparency of this surface. Something like this. So now we can see better look in the structure. Some details are highlighted with green for the blisters for the tendons. And for example, here, the reinforcements, let's check here for this main. So here you can see now clearly the segments. So check the rebar for this arc. And we have the first part, which is then the rebars which are generated or coming from this main foundation, just sticking out because they wait to be connected with all these couplers. So they use a lot of couplers here for each arc. There's couplers, not sure how many, but I think there are more than 1,000 bar in total longitudinal for one segment. So then we have the second part. So here we see now, this is the first or second part rebar, but this is for this segment. So you see there is a segment, here is also a segment. So the rebar, I will turn it off again. So first set, this is just rebar waiting to be connected. Then we have the second set. And again, it has also this rebar waiting to connect, and two sets. Yeah, so with a lot of overlap. And then we have the third part connected like this. Yeah, so each segment is done with this kind of solution, and within this 3D arc structure. So it's set how they constructed also segment by segment with the rebar. So this is also what is seen here in this picture in the case study. Okay, now let's put on some more reinforcement here. Like this, and this is then the rebar around this connection with the support. So there is a lot of rebar in there, which is also a very complex shape. So take a look here. So this is then also where the tendons will connect, and tendons in the sidewall, tendons on the top and the bottom. So for planning wise, seeing then this 3D model with the 3D rebar is very valuable also to just understand how it needs to be generated. And now let's take a look at the tendons. So there are a lot of tendons, I think about 120 in this deck, and we can just activate them. So let's activate here all. Yeah, so we have here this segment. You see here from the start there, and then they continue here from the blister. Some they end, so they see this is then for this structure. So depending also on the construction, they have these tendons going through. For the walls also, a whole set of tendons. You see going from the start all the way here to the end where they cross each other. And then also at the top, there are tendons here. So tendons is a very important part in this bridge. For now, they have been 3D modeled. With Allplan Bridge, you can generate this parametrically in each section, how this tendon would be, the variation of these tendons. Yeah, so now it's with a section long curve, you can design then the curve and make a 3D line out of that. Okay, so what I would like to show now here, let's turn off the tendons. So we have our deck, and maybe put the transparency off again so we can see the edges. So you see that this deck here, there is a curve. Again, there is a slight curve where it gets thinner. Then we have this connection with the arc. And I think the only thing that is not variable is the width of the deck. So the width of the deck, if you check, we have the walls. This width doesn't change. The thickness of the wall changes, the thickness of the bottom slab, the height, but it's just the width that doesn't change, but everything else is variable. Now, how can we create reinforcement in one step? Not the connection like we saw here, but let's say the main reinforcement that could be used through the whole deck to get quickly quantities or something, or see what design could work. I will turn on now the edges. So here we can see, just so you get a better overview, we see these green lines. There's the thickness of the bottom deck. We have this line here, which resembles the thickness of the top slab. So these are the edges that your reinforcement would follow. And I will focus on the main deck here. So we don't need to have the DTM at this point, and nothing of this, just the main span. So let's, and then we see here already one reinforcement, and I will just show, oh, sorry. So I will show now how to create some reinforcement like this. This is still a parametric reinforcement. So if I would check here, still selected, it's still being analyzed as rebar. I will show you now how to create something like this. So we have a section, and in a section you define your solution or your bar shape. Can be multiple sections. In this case, it's just one section at the beginning, and this bar shape will be used and will be generated by the lines that I have here. Maybe make it a little bit more dark so you can better see the lines. So for this function, I will use specific reinforcement. It's a sweep. This is similar to 3D modeling. You can have a sweep function or a loft function. This is similar to that, meaning you have a rebar, bar shape defined, and on your 3D object, I just generated here these lines so you can, it's easier to understand what lines they will follow. So this element needs to follow these edges and will be, the shape will be variable along these edges. Now there's one main thing that you need to do also here. You have to choose the main path, and this is the one that you see here in black, because the reinforcement should always be vertically and should be horizontally perpendicular to the axis. So there is one axis that you use to control how the bar shape is, the orientation of the bar shape. So vertically, because it can be independent from the actual bridge, because the bridge goes down, but all the reinforcement should always be vertically. Yes, so you have control over this to this level of detail. So here I will select then the edges. So this is the main path that I need to select. I will make sure that we see the whole path like this. Yes. So this is the main path. You can see it goes from the start to the end. And now I will select all the other paths. So here, if I move over the mouse, you can see then this is the edge going to that. And this would be for this point. Yeah. So I will select these edges. This is at the top. So that means these 4 edges give the orientation 1, 2, 3, 4 points. And then in the bottom, I just need these 2. So the other ones I don't really need because this one is just defined by 6 points. So 1, and now you can see the edges going all the way through the other side. So depending how many points you have in your bar shape corresponds with the number of edges you select. So let's say here I will use every 5 meters. Yeah. So okay. And now this is generated along this 400 meters length. And then you can see, and make it lighter a little bit again. So then you can see how it varies, but it also takes into account this gap, for example. And what we have, the bridge deck, the super elevation is going, so let's see, you can see that here it goes down to this side. So on the other side, it should go down the opposite way. And here you can see also that it goes the opposite way. This is because it's defined by the edges. So you have a bar shape that goes from left, and then if I take a section on the other side, will go to right super elevation. Yes, so this is what can be defined by the edges. So let's say, okay, not 5 meters. This was just to show what I would like to have. It's each 5 meters, like 50 centimeters, a half meter, and then you can see it generates just along the full edge, full length. So this 400 meters, this variable bar shape, so it's quite performant also. So here you can see no better what happens. So as soon as we hit this point, it uses this edge, and then you can see it follows nicely this curve and on the other side. So you have control over your actual, or because of your actual 3D model with the specific shape that has been designed, you can reuse this shape to generate quickly the main reinforcements. For the detailing, you can make them sections at this specific place to create a reinforcement into more detail. Okay, I think this is what I wanted to show for this project. Let's go now to another project. There are 3 more projects that I would like to show. So let's check here. The next one would be this one, but I will show here in Allplan. Yes, so this was the bridge. This is a railway bridge, which we said in the PowerPoint was not very interesting because it just has it just has one section. Yeah, so this is the section, and it continues the other way. Was it about 100 meters long? So it should be almost boring project, but the reinforcement detailing is complex. One, because of the tendons. Yeah, so it's a railroad, so it's heavy. It will be massively reinforced also. And then you see the tendons, but also, so here, so the rebar should be around the tendons, but in the side walls, okay, that's not too complex. There's not too much reinforcement, but then if we check the main decks, you can also see where there will be holes for the weight savers, like polystyrene blocks or something. So the reinforcement should be around that. But what is actually special, I'm still asking myself why they did it like this. You have in the bottom, you have supports which are diagonally. That means at each position, the height, so you can see this like this, the height of the tendon will be different. So if we check here, so this one will be higher than this one in the middle will be higher than this one on the top of this support will be higher. So because of this, the reinforcement on top of the piers, left and right side, and this is also not symmetrical, this is a little bit wider than this one, will be very complex. So what is the value here for 3D modeling and 3D reinforcement? It's again about how much you would like to be able to control during the design phase, let's say the construction. The engineering office, they just create a typical section. And they say, okay, we have a typical section created right here, where you have some rebar on top of the tendons and the bottom of the tendons, and then you just apply it through this whole section. So maybe there's a typical section here, which is okay because not too much variation, but then there is also one typical section. Let me tell you, this typical section doesn't exist anywhere in the project. So the engineering office, they say we create a typical section, then it's up to the contractor to define where they want to create it. And at this point, it's the contractor that wants to have control over it and wants to say, okay, we really need to have this in 3D because the tendon heights are fixed. They have been calculated. We cannot modify them. So we need to create a reinforcement around the tendons, but there is no 2D plan of how this actually fits together. So you create 3D model, then you create views and sections with a specific depth, and then you generate reinforcement at each specific slice. So where they say there is just one section, there will be 9 different sets of reinforcement or combination. Also, what is interesting here, if you see, you can see the different segments. Each one has a different length. So here, this is one segment, another segment, and this is again done by the contractor depending on the pour. So this is poured cast in place. So this segment together with this segment were the first ones. Then we had the ones at the end, this one and this one, and then the biggest one are the ones in the middle. There, and these two also. So this would be the last segment because they designed this like this with this length depending on the rebar length. So I will turn on some segment here. Which one? That doesn't matter. So this one here. So if we check now, we can see here that you have the rebar with the overlap length with 3 different lengths. So they chose a specific bar length, common with us is 12 or 40 meters. So depending on the rebar length that they had available, they can say, okay, we choose here. This is now a bar of, I'm not sure if it's 12 or 14, but this is 1 bar. So there is no overlap in the segment. The overlap is just here, but they need to have 3 different overlap positions to be able to get this bar length. If you have just 1 overlap, then you need to have a longer overlap length, and then this 1 bar would not, this length would not be sufficient. So they need to go here to 3 overlap lengths, staggering overlap lengths. So then the length of each lap can be smaller because they have staggered overlap. So this is then the solution that the contractor defined. So they can make this 12 meters or 40 meters. And then same thing from this start. So we have the overlap on this side, and then this would be the pour in between where the rebars connect. So then because of contractor wants to design with efficient use of rebar, they design it in these different steps. So then actually the rebar contractor has control over the different stages. The engineering office, they don't mind how it's constructed. They just say this is the whole bridge, this should be reinforced. Actually, how this is done doesn't matter as long as it's according to specification. Then the contractor has control over this. So we can take a look also on this side. And so we see here the tendons there with the different connections. And we also see the rebar along the tendons, for example, that we see. This is also quite special maybe because the width of the wall changes, and then we have this stirrups here, a little bit lighter. So we have the stirrups, and there are 2 U-shaped stirrups, and they have variable overlap. So that means the higher they go, the overlap will change, so they can fit nicely in this wall. Okay, so let's dive into one of these segments and more into detail, so we can see here what is actually the different layers or construction stages for the rebar to make it clear how this should be generated. See if it's better if I turn on the edges, so maybe a little bit too much. So I will just focus on this one segment. So again, we have the building structure, and in the building structure, these different elements have been designed. So you see you have preliminary design where we have the full deck. We have then the execution design, which has it's split up in these different segments. And then you can just activate the segment to focus on this segment. So let's just open this segment. Now, we have about 11 reinforcement layers at the top. So let's focus on the solution here for the tendons. And I will go by layer in this case. So let's turn everything off. And then we have our 3D model. We'll turn on the edges here, 3D model. Then we have the bearings, bottom. The tendons on the right, we don't need the tendons in the bottom. So here we see that these tendons, also the height changes diagonally, but because I don't have, or the contractor doesn't have any control over the height, he cannot assume that this height, because it's diagonal, could be symmetrical, that this height is the same as this one, because it has, the tendons has been designed and this is what is fixed. So we need to have a 3D model to be able to find out exactly how this, the height of the tendon is organized. Okay, now let's take a look at the layers. So we have a layer reinforcement, the first one here in the bottom, and I will turn off my 3D object. So here we see we have 2 bars, nothing special here. I will show later maybe where this comes from, and we have another one. So this is the solution where if the tendon is high from the typical section, if the tendon is high enough, this should be generated below it. But how many bars there will be depends on the height of the tendon. Yeah. So this is, let's say, layer 1 and 2 of the reinforcement. Now we have 9 other layers on top of this, and this would then be the most complex, layer 9 here. So here we have these different bars, and if I check, there are, each one is a different bar shape. So you see, I will go over like this. So alternating different bar shape. So that means what would be a typical section here in the middle, because this looks symmetrical, it's below this one, on top of this one, below there. But this is just a small section where this exists, because here there is just one bar where it doesn't work. This one is too high. Here you see the covered, but this is not covered. Yeah, so depending on the height, there is no way to generate this in 2D. You need to have a 3D model. You need to generate 3D reinforcement to be sure that this will fit. Now we have another layer, and then we activate the next one. And here you see everything is covered on this side, but not in the middle, but also not this one, because for some reason this is still higher than the one over there. Probably because it is inside and outside of this curve. It's slightly curved, that bridge. And then we have the other layers on top. So one more here. And then this is something, you see everything is covered, but also with a 3D model, you can do clash check. And now you clearly see there could be a clash right here, there could be a clash right here. This has not been solved in this model, it's not too important also. It's just to see that when the contractor generates, they say, okay, we have good rebar solution, we have a conflict here. What will we do on the construction yard? Will we just move it to the side and put an extra bar there? Will we move this? So then they can check at least where the actual conflict could be with the rebar and the tendons. So here, let's turn off maybe the edges again. Yes, and now there will be more layers. So one more covering everything now. And then there is 4 main layers on top. 1, 2, 3, 4. Because the railroad bridge, a lot of reinforcement. So that means there is no way of understanding this with all the layers without the 3D model to see where each layer would be and how the reinforcement would be generated. So we'll just turn on everything. So then you can see again, and here we can take a look in detail. So you can check, okay, there we have this tendons, go a little bit to the left, to the right, so you can analyze the different layers. But with this, let's say, going through the different stages, you can clearly visualize it. You can send it to the construction yard also with an image next to the drawing. This is the first layer, this is how it looks, because if we would only check a drawing, then this would be very complex. I had this talk with one of the engineers that checked the drawings, and let's take a look at one of the drawings. So this is the drawing. The only thing 3D about the drawing is this image. Of course, this is generated from the 3D model, but if you only have a drawing and no BIM model, no 3D reinforcement, then you have this picture, but I can also not see where the rebar is. It's just something that you can get an idea maybe. And then you get the design. This is then according to Belgian standard. And then this would be, or could be, a typical section. So here you see this is quite symmetrical, but this only exists on a specific place because there are these 8 other sections, or yes, 8 other sections which define and are slightly different. So in this case, you see here, this is not included, but on the right-hand side, there is a bar next to it. So it just all depends on the different heights, because this bar could continue over it, but here it cannot. So there needs to be a different solution. And then if you go to the other side of the diagonal, the other solution is different. So you have 9 sections in total of different bars. So here we see section A, and this is just this 9th layer of reinforcement where all the different, where you have all the different mark numbers. So you see them. This is a drawing. Looks very simple, but then if you know in 3D, this was actually quite a challenge to design it. So this is the drawing, which is just the result from the 3D model. But you can never know the solution if you do it in 2D, because you need really the 3D element for that. So 3D model can help very much with checking your first generating the correct rebar, so you have control over the faces and the construction. Can help with creating good drawings, because now the drawing, you're sure this is coming from a 3D model, so it's correct. It's not that you design something in 2D which cannot be constructed. So this depends, of course, from what importance it has for the construction. So for cost savings, this BIM work or this BIM approach is very valuable. Okay, this was it for this project. Now let's go to another type project that I mentioned here in the beginning. So this is the aqueduct. Like, there's a tunnel. Some people say it's a tunnel, yeah, but they call it aqueduct because there is a small canal for the boats to go over. This is in the Netherlands, so they have maybe some, competition or cooperation between roads, cars, and waterways, so highway and waterway, and this is a nice place where they are put together. So if you check here, for example, you can see it's also designed where there is a road on top of it. So it's open, it's half open, and then there is this part section which is actually a tunnel. So if you check here, we could go to the center or take a look here in the middle, for example. We'll take a good position. So here we see like rotating back. So you can check here, take a look at the different sides. And now we'll activate also the rebar in here. So this bridge model I would like to turn off. So the segment. So now you see we are here in this segment. And then I can turn on the rebar. And then we have here a rebar at the floor, all rebar. So here we can see then the rebar solution with these walls and these curved openings. So this was on the construction of the rebar for one of the parts for the aqueduct or the canal. Yeah, so you have a full model, 3D model, and then you have your rebar model. They exist next to each other, and you can zoom in or focus on the part you would like to see. Okay, now we come to the last reference project. This is the one in the Netherlands, flyover, a highway connection about 600 meters long. And what is special about this project, from the beginning, it was like a BIM pilot project in the Netherlands. So they thought before the project started about a good way to be able to generate or to manage the project with as much BIM as possible. And there were some interesting discussions in the beginning, because some people said, okay, this 3D model and BIM is all nice, but we first need to make sure that we get the correct 2D representation. Yes, 2D representation is important, but the goal of the project was to see how far we can go with BIM and 3D and get then, as a result, still good 2D drawings. So the approach is a little bit different, and some people need to invest and, let's say, take a risk to invest in the 3D model, generate 3D reinforcement, and then see what drawings you can get out of it. But because the workflow is a little bit different, if you do 2D, then you start with the drawing and you have a plan ready and there is no link with anything else. but you have your plan ready, let's say in a day. If you do 3D modeling, you can first do all the design, and then at the end of this phase, you will generate drawings. So you will have some time without any drawings, but after a while, you get all these drawings at the same time, and they're related to the 3D model. So this was specific because it was a cooperation between the engineer, the main contractor, and also the rebar contractor. And why is this important? Because rebar contractor could influence have his expertise to how this can be built efficiently. For example, if we take a look at one of these piers or piles of piers, the engineering office, they just say, okay, we do 1 bar from the top to the bottom, but this again is like, is it 2 meters or 3 meters thick? So there is a varying height of these piles, and they think, okay, we have one rebar solution, this is structurally strong enough, this is fine. But then the rebar contractor said, no, this is very difficult for us to have all these bars, and then we need to do it on site. The weather is not so good here, so actually there could be a lot of problem if they need to construct all these piers on the sites with do the rebar detailing, the rebar construction or assembly. They wanted to see if it would be possible to generate it in a workshop. So this is what I will show later for this project. First, we have this deck again, 600 meters long with all the spans. They need to have a good drawing also. So here, let's say the same thing with the section along curve. And here, this is what has been designed in the past with 2D functionality. These sections are still generated in 3D, but the overall profile is then done in 2D. So here, this takes maybe half day to generate it, to make sure that all the heights and everything is correct. If you use again this section along curve, just choose the axis, and this was special because it's not the center axis that was taken, it's the axis on the side, so it's also a spiral or clotoid with the circle, so composite element. And then it's not looking from the inside what you expect, it's looking from the outside. So you can just quickly choose the direction. And here, if I now position this, so it corresponds with their design, so that means what they did at the time was right. Also means this function works well, and then we can dimension the section, and then just click again, put this dimension or a label here, and then you can see it corresponds with the height of the section that we have there. So you can just click different points there, and you always get the height from the 3D model. So this is quick to generate and also to check and to label it, and so it's consistent and correct, because the length, this section along a curve, it's cut exactly along the axis that you have defined, and the length is a developed length, so it's very precise and it shows each object cut along the axis, and then you get a developed view here. Okay, so let's go now to rebar design, and we will take a look at one of the piers. So we'll go to the building structure again, like this. Maybe turn on something about the construction. Let's put on the different files of the structure. Okay. And then the rebar template. So we'll see again in the 3D model how the rebar is then located in the 3D model and some different stages. And then we will focus really on one pier, and then go a little bit more about what the relation is between 3D model and 2D representation in a view and a section. Okay, so I need to do something here also. We have, and after that, I will be showing some live demo part where I will be creating some rebar here. Oh, maybe I turn on too many different things, so it's still loading. Yes, okay. So let me turn off focus here. Yes, so we have the full model here, and then so if I turn off the main model, so now we have with the different, didn't turn on the pier, sorry for that. So we have the reinforcement model, we have a pier, and we also have the tendons here. So you can see that the tendons along the whole deck, and they have a special variation where they go like wider and higher. So this is also something can be quite complex. With Allplan Bridge, you can manage this and do this parametrically. So here we will check for the rebar faces, for example. So let me show the drawing files like this. Okay, and then we have the different stages. So, okay. Yes, this one we don't need yet. So about construction again, so this is for each segment of the deck. Like this, you can see the different stages. You can also see this polystyrene blocks, for example, and then we have the different, so it's constructed not from one side to the other. It starts here in the middle somewhere and then goes to this side first and then to the other side. So again, this is something we can visualize here. And I'll focus maybe on this segment 4, where it's connected with the abutment, and then we can see here the different layers of the reinforcement. So this is pour number 1, where they put like from the abutment, pour number 2, pour number 3, so abutment, and then, oh, this is for the column. I will zoom in on that later. And then we have for the deck also the longitudinal rebar, see here, and then the different, we have the transversal reinforcement, and then a lot of other reinforcement is coming together here for the tendons. And maybe I can turn off these different sets here, like this. So now it's really full of reinforcement, where we have the tendon heads, and then to the side also, yes. So we can also see here the different parts. Okay, let's focus on just this one column, and then here I will show the relation between the rebar and the drawing, or how you create actually or manipulate actually a reinforcement. So here we have one pile with the foundation and the foundation piles. What we see here is a 3D model with 3D rebar. So we can check again the bar reinforcement, for example. So you see you have 200 different mark numbers. And here, if I move over, you can see where all these bar marks are located. So it's again object tree to the, or the tree to the object level to mark number. And now let's take a look at where or how this is actually created. I will put this to the right, to the left, sorry. So we have 3D model here, isometrical view. So you can have multiple visibility or views next to each other. Maybe I don't need this one here. And then what we see here, this is a drawing, just like what we've seen in the layout editor. So this is the preparation of the drawing, but we talk about 3D rebar, and this is a drawing of 2D rebar, but this is still very much the same. So your model is a reference. There could be some sections created, but you see when I zoom in here and I select this bar or move over or hover over, then you see this bar being highlighted. Yes, so this is actually this bar. Same for this one here. Let's say I would like to change this rebar, so you can just click in a section. So this is a 2D representation of your 3D model. You see this is bar number 9. If I move over, you can also see with the tooltip bar number 9, it will be, of course, bar number 9 right here. Bar number 9, you can select it here also, and we see we have 5 times of 5 bars. Also in another section, you see this is also being selected, and this is 9 bars here. Sorry, number 9 and 5 bars. So if I would change one, and you can do this with direct input or through the properties. So let's say I would like to have 7. Then I can modify them here. And now you see in the 3D model, there are 7 bars. Also, the label has been changed to 7, but also in the other section, the label has been changed to 7. So I will go back. So one modification, 5, change it, and now we will have 7 bars. Yeah, so 3D model and 2D is the same thing. 2D is just a representation of what you would like to put on a drawing file. So you can very well create all the 3D reinforcements with all the sections that you need to create it. And then after that, or at the same time, the sections can be used to put on drawing, but you can create multiple sections afterwards to just create your plans. Yeah, so it works both ways. You generate reinforcement in your 3D model and you can modify it. Maybe I can show this right here. Not a good example, but just so you can see how this would work. So I can say I would create in this section a bar shape. So you just choose bar shape and I will place maybe bar shape, just design it there in the section from there to there, something like this. Okay. Nothing special. You can still say, okay, I would like to have this edge 1 meter and this edge also 1, or end segment, sorry, 1 meter. And then you can do the placement. And then depending on the settings, a rebar will be generated. You can make it generate automatically. Then you see here along the length where it can be applied, you generate in the 3D model, just with this section, a rebar. Yeah, so it's located from there to there. It detects the geometry automatically. You can also say, I would like to have it in a specific position. So it works both ways. 3D model, you can generate sections from it, from a specific place to give this detail. Like in the last example, there were 9 sections needed. And at the same time, you can create the sections to generate reinforcement in the 3D model. So this shows this relation, 2D drawings, 3D reinforcement, actually the same. You can use both of them to get 2 different representations, but the reference is a 3D model. So the BIM model is the reference, and you can create drawings, but the quantities and everything, the labels will show what is in the will come from the 3D model. So if you get rebar quantities, doesn't matter how many sections you have, like this bar, 9, 7, here also 7. I will not get 14 bars in a report. This will be just 7 because it's counted from the 3D model. Okay, now one more thing here. There are multiple sections, so you can create as many sections as you want. That doesn't take much time because you just create a section through an element. And then you see here, for example, a side view or front view from the pier. And then you would like to see here where these bars are located. You can just, again, hover over, select them, and then you can see them being selected. Here also, so you can see actually what is this bar about that they show in the drawing, where is it located. Same thing here, these are all these small stirrups. They're all different sizes. And then if you select them here, you can see them being selected. So you can say, okay, all these bars, they're actually at this layer of the pier and this height. Yeah, so you always have the relation between the two. Now, talking in the beginning about design. So what is special about this one is the design for the pier. So the rebar contractor and the main contractor engineering office, they sat together at an early stage. So while the design, or let's say the drawings, have been created by an engineer, the design of the rebar has been created by both of them together, because of course the engineer need to check if this rebar design would work. And then the rebar contractor can say, okay, I would like to have this as not one bar going through the bottom of the pier or so the foundation to the top, but I would like to split it, because that would be very efficient workflow wise. And then the engineer, of course, need to check it if it would be still structurally okay. So then let's come to the last part here, which actually show what this project then was about. We've seen 3D model, we've seen the design or the 2D representation, but about the actual design, and I have some images here from the project. So let's say maybe first here, so we can see, compare the segment that we saw in the beginning, and this is done on the construction art with the polystyrene blocks and the tendon heads or anchor heads. But this is what is really about. So because of the 3D model, the rebar contractor, they could design this in their workshop. So you see these bars, they're actually not elliptical. They just bend it with a couple of very shallow angle, or not a sharp angle. And they could design this whole pier in their workshop, fit it together so they can do an assembly in a controlled environment, not influenced by the weather. And then they could ship cages, they're actually located next to a river. So the first stage is really put on a river and then put them on trucks so they can design the cages so they can be transported. But they can all do this in their workshop, and they can deliver on site as it's requested. So they don't need to put tons of rebar on site for the people to work on the construction site to put the rebar together. They just create these piers and they're shipped to the construction yard when the concrete needed to be poured. And this is what we see in this picture here. So you can see these cages being slid in. There is one in the bottom. So this would be maybe 3 cages for this pier. They use formwork, which is very expensive and not so easy to get. So they can reuse now the formwork for the next pier, because they can maybe in a couple, I'm not sure how many days, but if you would need to construct the formwork, or sorry, the rebar inside the formwork, it would take maybe 15 days, a month to do this with a couple of people on site. But now they can just slide in these cages and then pour the concrete in just a couple of days, and then they can move on much quicker to the next pier, because they just have to get these from the workshop shipped to there. So, and then they have, because they have a 3D model, they have full control over the rebar. They put the cage together there, and then they're sure they can fit it. It fits on the construction yard. So for them, this exercise was really to efficiently design, but also to be able to efficiently construct. Efficiently means time-wise. So they gained a lot of time. I think this project was open, and this doesn't happen too much for an infrastructure project, 3 months ahead of schedule. So it was a success in that regard. And also for the costs for mistakes and things that needed to be solved, they had full control over it. They created it in the construction yard, so very efficiently, and not much and losses because of faults or mistakes on the construction site. So this was very interesting. Okay, I think this concludes the part with the reference projects. I can go now to some hands-on part. And maybe if there are questions about these reference projects, I'm not sure if there is a moderator that can help me with this. If there are questions, if we need to take a look at some questions, if it's about the reference project, I think I have a couple of minutes. I can answer them if that's interesting. And
Siswanto, I think you moderated most of the questions already away. Do you think there are some Stefan could answer right now?
Yes. If Stefan's finished, yes, I can start with a few questions. Okay.
so I will continue then with this part, and then later we can.
Yes, you continue first, and then on the Q&A session, I can highlight of the few of the question, which is you need to show on the 3D model, but certain absolute question that I can answer, I answer straight away.
Okay. Yes.
Okay.
So this is an example project, and you see here then there's a double curved deck, and you see also that this kind of abutment needs to then be created from this shape of the deck end. So I would like to show now some hands-on modeling, just some steps, so you can see how this works. There are 2 ways to do this modeling. You can do freeform modeling, but you can also do parametric modeling based on Python, for example. So I will show this part here. Okay, so let's go to a preview here. Okay, so we have our view here on the right-hand side as a reference, and I will turn off some elements here so we can focus on my section. So this is actually the bridge section, main section in the beginning, because you see here this is now flat. There has been a part taken there, but if you would take a look inside the bridge here, you would see that this is now, yeah, so this part here, sorry, I clicked somewhere on the wrong thing. Okay, let's check here. So here, make this lighter a little bit. So here you see this part is where the deck ends. So this is the main section of the deck, and we would need to create something for the abutment, which is slightly different. Doesn't matter exactly how, but in this case, this is because there is this part where you connect the deck to, so this needs to be a little bit thicker. For example, this is just like an example of how we can generate something like this and model. So I will generate this last section of the deck that can be added to the deck here. So we'll use some 3D, some freeform 3D modeling functions here. And I will mostly use something like extrude and shell to make objects a little bit bigger, use like some drag functions. So this would be extrude, for example. I would like to make this a little bit thicker. So like this, and then you just select the edge, select the thickness. So this is now 1 meter thick. Okay, and here now I would need to be make this, like we see here on the right and left, make this side a little bit higher and thicker. So I will create use the shell function now, and then maybe change the color so we can see what we're doing right here. So I will generate now here from this bottom, from this element, I will choose this edge or this surface and this surface. And now I will make something which is 2 meters down. So what does the shell do? It takes this object and then along the edges or the other surfaces, then generates the an additional object. So, okay, this is then something a little bit bigger. Now this is horizontal, so we'll need to cut it horizontally. So for this, we use a slice function. So select the object. So this is just still one object because I generated at the same time. And I would like to slice maybe through 3 points. You can choose a surface also, but from this point, it should be like 1.5 meters down. So I say minus 1.5, for example, and then you can see the crosshair, the red dot. So this is this point. And then you can use the track lines just to say I create now a 3D surface to make sure that like this. And then you see here, this is now cut. You can delete it. So we have now this part on the left and the right. Yeah. And now I can union. Union means you make one object again. The first one you click will be the property. So if this has already attributes and texture and stuff will be also transferred to the other one. So now I have one object, one full 3D object. So this is with some main functions like extrude, shell, slice, union, typical Boolean operations. Also, you can generate this object. So go a little bit further here. Use again the shell function now from the top. So from this object, I will use the top surface and then again along these edges, but here I would like to go down and 0.5 meters. Like this, okay. And then you can see here now this object, I would like to fill it to get to fill the hole so it's straight. So I will use now subtract, and I would like to keep my original shape. So I have the one that I will use to fill minus this one, and then you get 2 objects generated, and I can use again Boolean to union them like this. Yes, so this is done. Let's say this is almost finished. We just need to have this cut out at the top for the connection with the other deck. So we'll use here the extrude, for example, and then from this surface, and you can generate a whole, or sorry, extrude a whole surface, or choose on which surface you would like to extrude. So I would like to extrude on this point from this one here, and then I go down, it's minus, let's say 0.2, so 20 centimeters, to this point also minus 0.2, and then here. So this is now extrudes, and then you can see green will be adding to it, and you can see this also here. And then like I would say the depth now is let's say 0.2 on the other direction, minus 0.2, then you can see it red, and now this will be cut out. So let's say this segment is now finished with a couple of functions. Now I would like to generate this abutment. And what you see here, there is a gap, but the gap is different. Like this would be 10 centimeter, and this is maybe 50 centimeters. So I would like to take this shape to make the cutout for the abutment. So when you do 3D modeling, there are many different possibilities, many different workflows. It doesn't matter how you approach it. You can do this with different functions also. So I just show one possibility here. You could also first design this one and then cut out, but I will just start from the same object that I used before, so just from the surface. So I will use the shell again and make now color a little bit different. Oh, not the line color. And then select the object, and here I would use a shell and use the shell for multiple surfaces. So let's take a look on this side, because I would like to do an offset of all the surfaces at the same time. And I would like to do an offset from 0.1. So this is then the gap, okay, that is generated right now. So you see here, this is this 10 centimeter, but at the bottom I needed to have more. So I can use the shell again. Click element, so the green one now, select the surface you would like to have, and now I can say this should be 0.4. So because of the options that you can set here, you can choose, okay, it should be perpendicular to the surface, or it should follow the edges. So here, follow the edges is right, and then I have here now this part, the cutout of the abutment. So let's just union these two. Okay, so now I have my main end of the bridge, and I have this cutout. So now I can start with the abutment. So let's say this first part here, I will create a box. I'll use orange again, and now I will generate it also with some offset. So instead of clicking the right points, I will use relative points. So relative from this one that I have here, you can see here also. So let's say from this point, I will use a half-meter offset, for example. So you see this is in relation or relative to a specific point in your 3D model. You can use this to do modeling, so you don't have to, so you see here, put this on the point. You don't really need to create it first and then move it or change it. You can just do it like this to generate the object based on the relation of these points. Actually, I just wanted to show one point here because it needs to be wider, or it doesn't need to be deeper. So this is then 0.5 on this side, and on this side here again minus 0.5. Okay, and then the height of this section, or the height, should be something like let's say minus 5 meters. So you see always the preview, and then if you confirm, then you get this object. Yes. So okay, now you see this is wider a little bit. I could just generate it also and then extrude for like that, but you can enter it the first time right if you know this offset to a relative point. Again, here I will use the subtract. So from this element, I will subtract the main bridge. No, I will subtract actually this green part because that is the cutout. Would you like to split? Yes, because I still have this element that now can be cut. So now I have the abutment really taken over from this element with the depth here in the bottom. So now I don't need to have this green part anymore, so I can delete it. These objects can be parametrical objects. The bearings, you can design them 3D modeling. It can be like a smart symbol, a block, so many different ways to do this. Then you can get all the attributes from it. They can even be generated from Allplan Bridge, for example, at the right position. So here I will go now a little bit further with modeling this abutment, just 2 or 3 steps more. First, I will make this again a little bit thicker. So let's say 1 meter here, 1 meter. So like that. And now here I would like to create a block here on top. So also we can do this with extrude, but then with a rectangle maybe, or a polygon like this. Just choose the surface, and then you can say, okay, I would like to put it there, there, and in this direction should be 0.4, something like this. And then the height should be as high as the other object. Yes, so then you can see you use the other object's relation to model it, and I can do the same thing on this side. So use the extrude function, or just put a block also on top, doesn't matter too much, on this surface. And then from this point to this point, and now again, so you put your mouse for the reference, and you can give a direction, enter a value, and then click another point for the height. Yes. Okay, so here almost finished. It should make this a little bit longer. Now, again, there are multiple ways to do this. You can put a block there, or extrude one step, or multiple ways, or one element, other element. So I will use here extrude again, and then create the polyline. That means from a surface, again, select the surface, I can define now this shape. So here, click on the points. Maybe I can change the color so you can better see where this line is being created there at this point, and it will stay within the surface. So here it should be 0.6, for example, in this direction. From the bottom, again, and then go to the right, it should now be 1 meter. So I have generated the surface, and now you can set this here, and this maybe is like 4 meters or something. Yeah. On the other side, the same thing here. So click some points, take over the points, choose a direction, put a value, bottom 1 meter, okay, and then extrude to this side 4 meters again. So now I have this element almost ready. Now we'll create just one box below it for the main foundation plate, let's say. And here I will box, and then choose again these points. So minus 0.5 for the reference, so, and then 0.5 to the other side here. 0.5 minus 0.5, and then you can set the height is like 2 meters. So -2, for example. Yes. So here now I have these elements. For the representation, you can see texture can be automatically assigned depending on the color, but I can also say, okay, this object here, I would like to have assign it a different surface. So maybe from this project, I would like to use some other type of concrete, maybe this one, and then the object will be generated with this surface. Yeah, so different possibilities also for visualization. So now we've seen here, this is a freeform modeling. Now I will put next to it a parametrical abutment with Python. So Python is a programming language that you can use by yourself to generate objects for Python. So this open API. If you've experienced people with Python, they can create these parametrical objects to be used in Allplan. And here I will just take a standard one. A standard one from the default library, engineering, and here there is, for example, abutment. I can place it maybe at the same point as this one in the bottom here. You can see with the trackline references, and I would like to change it with an angle of 90 degrees. So it represents more or less the same point. So I place it here. We'll just escape. You can see there are handles. There are a lot of values here. But now this is a parametrical object. That means I can modify it after a placement. The other one, 3D modeling, can still modify it with the Boolean operations or 3D modeling functions. But this one is generated by parameters. That means for some things, it can be very easy to modify something. So I just double click it. For example, we have the angle between these two, between the wing wall and the main support for the deck. This angle can be changed, for example. So we have wing wall here. should be now 60 degrees, for example. Then you can see, you can just put a value here, or it can be a handle, and then this object will now be different. If you need to do this with modeling, then you need to slice, you need to cut, you need to change some parts. So this is very user-friendly and quick. And it can be, with the Python parts, you can make sure that it follows some rules or parameters or things that you have set that make sure that the object is not out of specification. So here, let's say, you can take this one here, and then you can make it also wider, and then you can see what happens with the bottom element. So everything is linked. You can make this a little bit lower. You can make this also wider. Yes, so you can quickly adapt it with parameters. So this is then the advantage of a Python part, where you can change parametrically and still be able to modify it later. Okay. Then maybe the last part right now, and I will go into some reinforcement. So I will open just this one file that I have here. Maybe we don't need to have the parametrical element anymore. Okay. So now I'll go here to a plan view, wireframe. So this is the top view for the 3D model, and I will create some section or visualization from this element, similar to what we've shown before with the pier, but now go step by step also with the views and sections, and then generate a couple of rebar. So views and sections, you can generate a section around the element through part of the element. So let's say I would like to have a front view in this case. I will just put this here. This is a front view. You can also configure how you would like to see it. So can be, would you like to see bitmaps, for example? I will just place it here and then modify them afterwards. So this is one view, and I will create another one with the same boundary of the section, but now a free view. So it will be an isometrical view, and I would like to take over this view here. So I click on the right to take over this view, and then I will get this representation. So again, how you would like to see these elements with the bounding box, with the colors, these are things you can configure. So let's modify both of them here. I would like to modify both of them. I don't want to see a clipping path, for example, and I would like to see them with some textures. So that means the same textures that we use here. And I would like to see shadows, maybe. Not sure if you'll see anything. And maybe for layers also, so you can choose in these two. I don't want to see maybe any reinforcement layers. So if I would use reinforcement, I don't want to see them here, because this is for representation and not for reinforcement. So you have now your two elements with the references I've set here. Maybe is the shadow is not. So here you can see also how you can set the shadow, maybe 45. Do I see something different then? So here you can see now there's a little bit of shadow. So depending on how you set the values, you can see a different kind of shadow, if you need to have this. Yeah, so, okay, that's fine here. Now let's make a reinforcement section. Maybe we'd like to place some reinforcement just in this part here. So I will create again a new section. You can create a section from a section. So let's say from this one, I would like to create something where I see this part, for example. And I would like to look from this side, just to have a view from the section. And in this case, I don't want to have any texture. I just want to see this here. So it means no shadow or no light, anything. Maybe, and this is just a view. And now I would like to create a section again from this one, or from the model also. So you can choose wherever you want to create your section from. So let's say I will create a section here that shows this part. And I look from this side. And now for this section, for this section, so hide from the elements, like this. Okay, so again, nothing from this setting. So these can also be a favorite where you configure it how you'd like it to look. You can also set if you want to see clipping lines. Would you like to see hidden edges? Would you like to see a filling when you cut something, different elements or different parameters, line thickness, line colors, things like that. So here you see the object is now just a black line and filling for the section, so you can see its section. And now I would like to maybe turn on this one here, some hidden lines, formats. So you can do this whenever you create a section or modify it afterwards. So here I can see now this hidden lines. So I would like to place reinforcement here and reinforcement in just this top part. Very simple, just to show the workflow. So create views and sections. And then here I will create, you can see there are multiple bar shapes that you have. You can set here also, choose from the schematic. A bar shape is defined by a steel catalog, cross-section catalog. So depending on the cross-section catalog, you can have different diameters, and depending on the standard that you have, the calculation will be different. So here you can choose different kind of standard, ACI, British standard, Euro norm, and also concrete cover are linked to the standard. And for the labeling, for example, you can also choose how this label should look to make it sure that it's localized. So different countries have different types of labels, so you can just choose for how you want to see something and in what position you would like to see something. So you can just drag and drop. This one should be another position, so you can configure these labels also. Next to that, we have a cross-section catalog. So the cross-section catalog is something that you can also define or can download, and there are, depending on the country standard you have. So I'm working with the Belgian country standard, so I have the Belgian cross-section catalog for my rebar, and then I have different diameters, different steel grades. So you can also modify one where you say, I would like to have different diameters with different settings. So this is all taken into account when you create reinforcement. So here I will generate reinforcement, just a free form, and just click some points. So I click points in the 2D section, taking over the edges. Diameter 25 doesn't matter here, it's quite thick, but okay. And let's say here, in the two segments should have the same length. Both of them should be 2.5, for example, and this should also be 2.5. Bar shape is generated or created, and now you can see also that the placement is done automatically if it's the full length, or I can say I don't want it to be the full length. I would like it to be just from this point to this point. And then you can see that you can control by yourself where this rebar should be generated. Okay, or I would like to define it again from this point to this point. Yes, and you can set spacing should be different, maybe 0.2, for example. Things can be set, or you want to have a number of pieces. So this is, let's say, the first bar. Now, for the next bar, I would just use a straight placement. You can create it with free form or here and just make it react to some of these lines. So, okay, 25 doesn't matter also. For the placement now, I will place it against an existing bar. So instead of defining the position myself, I will say, okay, place it against this edge with a spacing, or so you can see it will be generated along this edge. I can say it should have a spacing, or it just have a number of bars. So I can say, okay, just put 3 bars there, or I would like to have a spacing of 0.2 also in this case, or 0.5, for example. You can modify it. You can also modify it later, like we have seen before. And then we have the rebar in 2 different views, also in the 3D model. So let's turn this transparent maybe a little bit, that we can see the rebar here. So rebar in the 3D model. And now I will do some representation. So for this one here, I would like to see just the middle bar, okay, and for the horizontal bars also the middle bar. And then I can add some labels to it, maybe with dimension lines. So here, this configuration comes from the options. You can still set, if you would like to see the spacing or other things, you can define also how it should look. So I will use a dimension line with dimension line options here. So, okay, this one is placed from there to there. Okay, dimension line with the label, wherever you want to put the label. And this one here, for example, should be there. You can say show bar markers, for example, that you can see here also that it with what bar it links to. So we have here these 5 bars, diameter 25 every 50 centimeters, and we have every 20. So this can be set, should be millimeters, should be meters, things like that can all be configured. And as the last part here, I will do another type of label where we have a COM, for example. So we have COM, maybe I can show the difference here. So select the placement here. You can see all bars are selected. You can still choose, I would like to have a dimension line with a preview, or I would like to have a fan. And then there are still different configurations like this. Would you like to see all leaders or no leaders, or just a start and end leader? So many things can be configured for this label. I will go to the COM. And then for the COM, for example, we have here with the different offsets, and then you can place this part like this, for example, or below. Up to you how you would like to define this. And maybe this with a normal label to the other side. And depending on options where you are with your mouse, you can also say, okay, it should be automatically positioned. So we have bar mark 1, 2, nothing special in the 3D model. If you go back to my object palette, we can, of course, also see this here. We have bar reinforcement. We have our different bar marks. So wherever I select them here, you will see them in all views and sections. Same here. If I select this bar here, you can still modify this. For example, with the direct inputs, should change the values, should change the length or the distance in between. And maybe as a last thing, I can put a schedule next to it. Just a very simple legend. And then we get here the overview of this bars. So this is taken again from the model. So if I would modify one, and I will put this here bottom. So let's say if I change now placement, for example, here of this open stirrup, I would like to have it every 30 centimeters, 0.3. So that would mean you see the label changing here, 20. You see this label changing, and also, of course, you see what is changed in the schedule. So you don't need to manually recalculate, check your drawings. Everything is coming from the reference 3D model, or quantities and all labels come from this 3D model. Okay, I think this is everything I wanted to show. So we've gone over some reference projects, civil engineering, some bridges, mainly based on these case studies that you can find on our website. You can download the package with all of these case studies and give you behind the scenes of this project, how they're actually in Allplan designed, what you can do with this 3D model rebar, and then some hands-on last, some introduction into 3D modeling and rebar detailing. So this was it from my side. Thanks for your attention. Siswanto, are there
Yes.
questions you would like me to answer?
Ya, Pak Reza, masih di sana Pak Reza? Pak Reza mau memberikan penjelasan mengenai link untuk absensi Pak Reza, atau sementara saya bisa jawab dengan question and answer dulu ya. Oke, Stefan? Well,
Yes.
please prepare yourself about the class check ya, while I'm answering another question ya. They want to see the class check between the element or bar and everything. You want to show it now? Or?
Okay. Yes, I can show it.
Oke, jadi ini pertanyaan dari tadi ada beberapa yang menanyakan kalau di dalam Allplan bagaimana kita melakukan class check, atau bagaimana kita yakin kalau pembersihan kita nggak bermasalah, akan ditunjukkan oleh Mr. Stefan. Go ahead, Stefan.
So yes, if I will copy, let's say just one bar here from this side, I can select just one there. Oh, I put all of them. Okay, so maybe here, let's say I will create just one bar, straight bar. At the top, maybe diameter a little bit bigger, 32 or something. Okay, just do one placement then. And place it there at the top. Maybe I would like to have 2 pieces, something here. Okay. And then this bar I will now position so there will be a clash. Yeah, so I will move this bar here, move it so it will be there somewhere. So now you will see there is a clash. Yes. So if I do the clash checking, And now I need to check where this clash checking is. Collision check. So, and you can select in your 3D model, for example, or a whole thing. So it depends on how many elements there are. And now you can see there are 40 collisions created. So for the collisions, you will see them being highlighted with red crosses in your 2D design. And also in here, the 3D model, you will see them with these boxes. So there is clash check between 3D rebar elements, and you can also save this clash check on a different drawing file to check later. This is only hard clash, so there is clash between 3D objects, there is clash between rebar objects, but there is no clash between rebar and 3D elements because rebar is mostly inside of 3D objects, but there is also a clash between fixtures. So let's say anchor head could be a fixture or an insert in the concrete, and rebar can also be checked. But it's a hard clash, so there is a clash or there is no clash. In BIM Plus, we can have different kinds of clashes. There you can have a clash where you have a tolerance, or clashes where you set between different types of element. So in Allplan, it's a very basic clash, just to see if you create something would be okay. Then it's up to you to define how it should be, but it's mainly for reinforcement and 3D objects. BIM Plus can do more things. Okay, that's it for my answer.
Oke, untuk rekan-rekan semua, saya mencoba menjawab beberapa pertanyaan yang timbul tadi. Salah satunya adalah mengenai clash check, tadi sudah dijelaskan sama Mr. Stefan. Terus ada yang menanyakan kelebihan daripada software Allplan dibandingkan software-software lain. Menurut saya, kita nggak bicara dengan software lain, namun kita percaya bahwa software kita ini bisa dipakai untuk membuat segala macam jenis building. Kita tidak terbatas hanya untuk infrastruktur saja, kita bisa dipakai untuk arsitektur, kita bisa dipakai juga untuk building, kita bisa dipakai untuk infrastruktur, jalan, jembatan, elevated, dam. Tadi yang menanyakan juga apakah bisa dipakai untuk dam dan seterusnya dan seterusnya. Jadi cukup luas. Stefan, are you able to show me about the DTM module, our DTM module, because they are questioning how we are collaborate with the data which is coming from site.
Yes, the main thing would be if you have a point coordinate file, this can be just a file with XYZ coordinates. This is something you can import in Allplan, then a point mesh will be generated. Or you can also go with LandXML. So LandXML can also have a point coordinate file, and this is something you can import. LandXML, you don't have to configure anything because it's a standard for this terrain. So you can just say import LandXML. Or if you do with a terrain module, then you can go to surroundings terrain, and here you can import a point coordinate file. So this is something where you just have in a text file or an Excel file, XYZ coordinates, you can import in points, and then you can mesh to make a terrain out of it. And then the terrain you saw in the first bridge, the Versammeltoll bridge, that was an actual terrain being generated by mesh.
Okay. Stefan, are you still able to showing the 360 video? I believe you have some 360 video because you never mentioned about this, that Allplan have the capability to create a 360 video. Yeah?
Yes. Okay, let me check. I have something, but I need to check it. Yes, right. So when you do rendering, maybe I can just explain this here a little bit. So when you do rendering in Allplan, you can also choose that it should be a spherical rendering. So this is then a 360-degree rendering. But I will check here if I have some examples for it. Other question?
Yes, collaboration with other software. I believe that I can answer this because kita sebagian besar bisa membaca format-format yang standar ya. Tadi ada pertanyaan bisa membaca format apa saja. Allplan bisa membaca format DWG, TXF. Kita bisa import dari Google Earth, 3D Studio, MicroStation DGN. Kita bisa kolaborasi dengan Excel, HTML, Word. Kita bisa VRML, Rhino, SketchUp, 3D PDF, 2D PDF, IFC. Tadi ada yang menanyakan juga jenis IFC apa yang bisa dibaca oleh kita. Kita bisa kolaborasi dengan seluruh jenis IFC. Bahkan kita sebetulnya juga lagi mengembangkan IFC 4.2. Saya rasa hanya Allplan saat ini yang masih mengembangkan 4.2. Jadi cukup banyak file yang bisa dibaca di Allplan. Sorry, Stefan, I'm answering about the
No, it's
what
okay.
kind of the type of the file that we can read.
Yeah.
Okay. Do you want me to show my screen? I don't know how to show my screen. I will screen. Okay, let me see my screen. Can you see my screen?
No, I'm still presenter, I think.
Oh.
So should I stop then? I will stop. And then
before you stop, can you show me the normalization, like Rebar normalization standardization?
What do you mean exactly by that?
ACI, like bending radius and something like that.
Where this comes from?
Yes, and then also the 12 meters length. When you create more longer than 12 meters, it will be spliced automatically. I think you need to show that.
Yes. Yes. Okay. So yes, I will share my screen again then. Share. So wait, now I have to activate. Can you see my screen or not?
Not yet. Yes.
Yes. Okay.
Yes.
So about the rebar setting. So I went briefly over it in the options. So in the reinforcement, you have these standards that you can choose from. I will show later where they are configured, and also choose what bar length you will use. Yes, I'll make this smaller again. So these are some main settings that you can do. And for what these actual standards are, this is also open. So you can create your own standard and add it to the list of the standards. So it can be a project standard or a customer standard. But because this is open, so these are text files. So if I check, for example, national code in the Allplan installation, here you can get an overview of the list. So these are the national code. So here's, if you check ACI, it's 16. And in this file, you will have the overview of this element. So let's say if I check settings, for example, settings, there is then written here what the concrete cover is, for example, or what is the length or the hook length calculation. This is quite complex for ICI. So here you can see there are some rules in it. If the hook length is smaller than this, if the diameter is different, so everything is then configured with some formulas. So what is built in are the formulas from the standards. So if you take a look at Eurocode, this is then Eurocode. Is this here? Oh no, this is the wrong one. National code. So again, we have the Euro norm is 19. So we can check here 19, and then about the hook length or the offset or bending roller diameter, for example, then you can see, okay, if the diameter is larger than 16, the bending pin should be 7. If it's else different than 16, it should be 4. And these things we can see also in when we create rebar, then these things will be used. So if I take here now the Euro norm, for example, and I just choose here Rebar Engineering, what we will see here, let's take closed stirrup, for example, then you see this is now the bending pin factor 4. If I choose something bigger than 16, you will see the bending pin will now be 7. Same thing with the hook length. So hook length is now 29 centimeter. If I take another diameter, the hook length will be different. So this is all calculated from the standards. That's answer to the question? Yes?
Yes. Jadi pertanyaan mengenai standar apa yang kita gunakan, kita bisa memasukkan SNI, kita sudah punya standar ACI. Pada dasarnya kita bisa rubah sesuai dengan kebutuhan karena biasanya tiap-tiap project bisa berbeda. Jadi bending radiusnya mau berapa, terus panjang hook length-nya dan segala macam itu sesuatu yang bisa kita konfigur. Jadi pada dasarnya kita fleksibel. Itu untuk menjawab pertanyaan mengenai standar apa yang bisa kita pakai. Stefan?
Yes.
Or maybe Ramon is better to answer this. Ramon, are you still there?
Yes, I'm still here. I'm still here.
Ramon, there is a question. What is Allplan Engineering? What is Allplan Architectures? And what is the Allplan Bridge? How our position ourselves? I think Allplan Engineering is, we have two products, civil and building. Can you present something like that? Because there are so many questions about Allplan Engineering, Architectures, and Bridge, even though you show already some of the presentation before.
Yes, so in fact, if we speak about Allplan itself, there is, in the basis, there's one program, and that means that the basics, what is an Allplan architecture, are also in the Allplan engineering versions if we speak for the building side. An architect needs to create walls, columns, beams, and slabs, and an engineer needs to do that also in building. So that's the same package. If you add to the Allplan architecture the reinforcement module, then you end up with the Allplan engineering version for buildings. For civil engineering, however, and the freeform modeler, I must say, is of course also in those versions. If we speak about civil engineering, then it's not necessary to have those architectural modules. So they are not in, but a civil engineer, he needs the terrain modeler and dedicated modules for civil engineering. You can add them as an option to Allplan architecture and Allplan engineering for building, but they are automatically included into the civil version. But to summarize it, Allplan is in fact one and the same package with dedicated modules for each discipline. Allplan Bridge, however, and that will be covered completely tomorrow, that's a parametric bridge designer, what is a separate tool on top of Allplan Engineering. Together with Allplan Engineering Civil, Allplan Bridge builds the Allplan Bridge solution. But we will see that in detail and demonstrate it to the max tomorrow. Does that answer the question?
Yes, yes. Oke, tadi juga ada pertanyaan mengenai rendering ya di dalam Allplan. Yes, go ahead. I'm ready. Enough.
Yes.
Thank you, Ramon.
So this is the 3D. Yes, yes. So, okay, so this is just with the Windows Movie Player. This has been generated from Allplan with an example bridge, which has been created with the Allplan bridge. So you can see here, you can just go through, but then if you pause it, let's say pause here, and then you can just look around. Yeah, you can also look around while you're playing, but then it's of course a little bit more confusing. So yeah, this is one example here. So a good way to show projects. Same here as the one we show. This one not. Movie player. Oh yes. So here, okay, I can go. So you can control it. Pause. So this is the one that we had before. Remember that Aqueduct thing. So here there is a movie clip generated from this project, and then you can also say, okay, I would like to look around at this point where there is reinforcement. So just with a movie clip, you can give somebody information, and they can like experience this and checking something in detail. This could be a handy format for presentation, or just to yeah, here also this one, so you can look around while you're playing and check, okay, here in tunnel, look up. So yeah, this is, I'm not sure how well it plays through the GoToMeeting, but the thing is you can just pause it and you always have then the possibility to look around at any position. This is quite interesting, I would say. Okay, that's it.
Thank you. Untuk rekan-rekan, ini adalah salah satu output yang bisa dibuat oleh Allplan Engineering. Jadi merupakan sebuah video, tapi merupakan 360 video. Jadi kita bisa berhenti tiap saat dan kita bisa lihat ke kiri, ke kanan, ke atas, zoom dan segala macam. Mengingat waktu dan tempat, saya serahkan ke Pak Reza lagi. Mungkin Pak Reza mau memberikan link untuk absensi dan segala macam. Untuk pertanyaan-pertanyaan yang lain yang belum sempat kita jawab, akan kita jawab secara terpisah karena kita mendapatkan lebih dari 450 pertanyaan. Jadi akan dijawab nanti melalui email saja. Silakan Pak Reza. Ari, can you give the access? Ya, oke. Silakan Mbak Reza. Ali, can you give the control to Mr. Reza, audio, to share the screen?
Oke. Share materi di mana lupa aku. Yang ini ya? Oke, Bapak Ibu semua, ini kita webinar BIM Allplan yang pertama hari ini sudah selesai. Ini mohon maaf ini memang kita baru pertama kali nih mengeluarin informasi link feedbacknya lewat webinar ini ternyata nggak bisa ya, beda sama Zoom caranya. Oke, saya mau share ini linknya di mana ya? Nge-share nggak bisa ya.
Alec, can you give control so Mr. Reza can share his screen?
Yes, presenternya oke.
Oke, already presenter Pak.
Thank
Bapak
you.
tinggal share screen Pak.